Hello everyone, in this video I'd like to demonstrate a complete project that I've been working on recently, so I call it Arduino Smart Home System. The idea is the following. I have the Arduino Mega 2560 with Wi-Fi, ESP8266 being embedded onto this board. Wi-Fi is here. They do interact over the serial port 3, the hardware serial. This is the switch, also the dip switches. Needs to be set up properly. I've been talking about this in the previous video for quite a lot. So currently I have a web server running on this thing. So I can connect to the web server, assuming I am connected to the over the Wi-Fi to the local network from whatever device. And I will now do connect from my smartphones. So in a browser, I'm going to this 192.168.121, and I just go there, and it loads the application. This is the simplified version of the application that I've been demonstrating in the very first video within this series. So you just have a look over in here, and here we have the pin 13. So now I enable pin 13 in the application and it lights up. Disable, enable, disable. So this is the basic functionality. The idea is very simple. This application sends the HTTP request to the web server that is running in here, and it gets passed, and the pin number and the state of the pin gets updated. And another interesting option, if say we want to set up the pin, okay, so this is like light up now, but then let's say I just turn on the phone, turn off the phone, then I just re-enable it back, and say I want to reload the page, I just do this sort of a thing. And now once I've loaded the page, it shows me already that pin 13 is currently being on. And that's working because there are variables that do store the values of the pins every time when the digital write to certain pin occurs. Now, another interesting thing, so I'll probably just put the smartphone here so that you can see this as well. I think this would be visible like so. Okay, maybe like this. All right, so now we have the same application on the web browser on my computer. For instance, if I just do upload, like update things, reload the page, you see already this pin 13 has been activated, and on board, indeed, it is activated. Now, if I want to switch this off from another device, I can do this, and now it gets switched off. And now, to make sure that on a smartphone the state also gets updated, I just need to go to this page and update it again. And after, you see, like, it's absolutely like clean. Now again, if I want to turn this off, it turns off, turns on, and on the computer, I just update the page, and we also get this state being updated. Now you might be wondering why not to automate this, why not to do this like happening in the background. There are some reasons. I would like to explain those in a bit more detail. So the idea is the following: if we have so here, once you can have a look at the serial monitor. So since my Arduino is currently connected by the USB to the laptop, so that every time request occurs, here we can see what's going on. So let's probably reload the Arduino and have a look at the particular, like what's happening in here. And I could probably even just try to restart the monitor like this. Okay, so serial monitor, yeah. So it connects to the local Wi-Fi. This is the SSID of the Wi-Fi. It initializes the Wi-Fi module. All this works using the Wi-Fi ESP library, which has been mentioned in the previous video. It's making an attempt to connect to this SSID. Now it's connected. The server, the HTTP server, starts on port 80. And it tells me like you're connected and the web server is running. So this is how I can know which particular IP address do I need to visit in order to see the web page. Now, if I just update this, okay, again, currently on board, you see LED 13 is not being light up, and the state is synchronized, so the application shows this exact thing. But every time we do upload the page, so we'll now upload the page, and you just watch here. It gets it establishes connection, sends the HTTP page back to client, and then it just closes the connection. And when I'm doing the setting up the pin, you see like here the Ajax request files in the background. It's not a post request. I've been trying to play around with the post request, but those doesn't seem to be that nicely supported by the Wi-Fi ESP library. So instead, I'm just doing the GET request and just sends in the state and pin and the state parameters as the URL parameters essentially. So, but again, every time I do this, you see like here, a new connection gets established, and it also gives me an idea. So setting up pin 13 to 1. Oh, I need to add a space there. And now setting pin 13 to 0. After a device like either requests the page, or maybe it just, can I just try to turn this off? Lights up, lights off, turns off, and here, update, again, this state has been synchronized. So yeah, the idea is that if we have a connection that is living only when the request is sent, then the connection dies. In this way, we can do many kind of connections, not essentially not simultaneously, but well, if you try to switch in both devices simultaneously, it might not work on one of those. But anyway, the idea that you can just do this from one device, from another device, and yeah, sort of being synchronized in terms of if you just update the page, it gets synchronized. So that's the idea. And now finally, you see like the HTML has been significantly simplified as opposed to what we had in the initial prototyping video. And the reason for that is following. So I just want to show you the source code for this. Sorry, I'm using Vim because it's not really comfortable to me to do this in the GUI. So this is the standard sketch for the sketch I've taken as a basis is from examples, Wi-Fi ESP. I've installed this library, and web server. This is the template I've been using, and then I've made some changes to the template. So currently, so these are the headers that are being sent to the client, no matter what the client is, whether this is the computer or the smartphone. And then pass root does exactly this thing. So this might be the root, this might be switch. Switch is used for the asynchronous request, so that when I click here, it just does this asynchronous request. Okay, and again, let's light up. So this asynchronous requests are being sent, and when the request comes, so when in the browser we have just nothing, just the IP address, like in here, it sends this HTML in response. We'll quickly walk through this now. Otherwise, if we just send the XHR request, which is done over in here, so I'm sending the XHR request, it's the GET request, switch, and the parameters. And essentially the parameters are, we want to set the, I'll just make this full screen. We want to set the ID pin equals to, and the ID of the checkbox is serving as the pin number, and also the state is the state of the checkbox. So this is how we synchronize the front end and the back end. And then another interesting thing, so that we could dynamically generate the HTML on the server side, and so that the HTML represent the exact state of the internal pins of the Arduino. Here we stringify pins. We're not stringifying pins. We're just using this checked. It's not flag. It's just an attribute, HTML attribute. We add checks to the checkbox input element in case if pins indexed by this number by the ID has the value of true or one. And now how that gets populated. So we have a data structure in the beginning, just called pins. Currently it's supposed 14 pins. And every time we get to the switch root, here, setting up the pin, it just prints the pin that is passed and the state that is also passed. And now, pins indexed by the pin get set to this with the value of state, so just an array, and then digital write to the pin and the current state. So this is the synchronization of the internal data structure of pins with the actual hardware state of the Arduino board. So this is the synchronization during writing data, and here above we have the synchronization during reading the data. So whatever value has been set to pins during the last switch, it gets read from there, and if the value is true, it adds the checked attribute to the input type checkbox. And in this case, essentially, we can see, like, let's say we close this entirely and then we just open a new one, just go there, and whatever pins has been set up. So this reads from the pins array from the Arduino. But again, this is absolutely synchronized with the internal state. So like pin 13 is light up, and here in particular it is light up. So I just turn this off, it gets turned off. If I update, then again, just no longer there. And if I update on the smartphone, we have exactly the same thing. So I just update on the smartphone, and we have only the first pin being activated. We cannot see this, but anyway, hopefully this makes sense. So yeah, guys, this is it in regards to the project at its current state. Many other things can be added, but again, I could not do the full-blown web application as I was intending initially, because if you have this HTML document too big, it's not capable to send it, so you need to split this into chunks. That's complicated, and also that takes ages. And now the problem that all this lives in the random access memory, so if you try to put this into the progmem, to the flash essentially where the sketch lives, in this case, when you start reading this, it takes too long because it involves the serial communication, and just too long to do this because it interacts with the ESP82, 86. Oh my goodness, I've got what's the 8266? Yeah, Wi-Fi. So just slow as hell, and then web page loads for 10 minutes or so. It's just horrible. So since we are limited to only 8 kilobytes of random access memory for the Arduino Mega here, so we cannot use that big amount of data for the web page. So that's one limitation. So all this essentially, well, I'm not sure, but I think this should live in the random access memory. To check this out, we can see the output. Yeah, it uses 28% of the dynamic memory. So for all the variables, essentially, so all the variables, this 28% is currently being used for this particular web page, because all the strings are essentially like variable space. It's not on the flash where the sketch is, where the code is, like this, but it's on the it's in the random access memory. Although these are the string constants and not being explicitly defined as the string constant, but in C++, these are the constants, and they are saved implicitly in the random access memory, which is represented with this value of 28%. So yeah, some limitations are there. So if you do turn this on and off very quickly, it also might just skip some options. But again, you can anytime when you feel like something goes wrong, you can just re-upload the page, like update the page to see the actual state. So it might be some delay sometimes. And again, the reason why I'm not doing the background updates for the web page, so I could either send the refresh header with a response on the server side. That's the simplest way possible. But in that case, on the client device, it would be just flickering the update every time. It could be done without flickering via the, again, another AJAX request that would be updating the state. But again, you mentioned that the AJAX request updates the state, and in the same time, user clicks to toggle the switch on this device or on the other device. And this may result in a conflict because essentially it's not asynchronous. So it now updates the state, user clicks, it's not being recognized, and the device does not work. So to avoid those nasty scenarios, since Arduino is not like for hosting complicated web applications, just for controlling, remotely controlling the internal state of its pins via the Wi-Fi. That's it. So in case if you want to have a full-blown user application, having the name of devices, pins, all those fancy tables like I'm doing in the original video of prototyping things, the web server should be running separately, and it just should be interacting with the Arduino server via the API, for instance, so that Arduino server can do the particular backend stuff, like turning, like writing to pins and reading from pins. Essentially, that's it, without pretty much caring about the interface. But since that's not free, so you need to pay for the web server that will be running somewhere on Amazon or whatever. So to make it free and usable still, we can just limit ourselves with a minimal web interface provided over in here. And with this minimal interface, we can, at the same time, we can still control Arduino from the smartphone or from the computer. But it's not that fancy. You don't have a login. You don't have HTTPS because it's not implemented in the Wi-Fi ASP library, etc. So some limitation. But since you're using this within the local network, this is like okay. And even if you want to forward this server to the outer world, although insecure connection is not really good, but since this might be done via the passwords to access to your router, so like some outer firewall security measures are available there anyway. So once you're allowed to go to the inner network from the outside, within this inner network, you can do with this insecure connection. That should be fairly okay. Although this is arguable, but anyway, just trying to figure out, to point out all those possibilities available. So yeah, guys, this is it from my side. Thanks for watching. We'll probably be posting some updates on the project when I would be adding some more things to it. So one of the next upcoming things is to add 2 relay modules here. They are about to arrive in a couple of days, hopefully. Then maybe adding some sensors to not only control the output pins, but also control the input pins, maybe some automation, like based on the sensor value, the temperature, trying to control the pins, responsible for heat, for instance, something. So some automation scenarios are also possible. So I'm not sure where this goes. Essentially, the project is not the general solution for like smart home. This is intended to be as a particular solution for the particular need for a particular client. That's the idea. So you have a client, he wants to automate his home some way, and this is the custom solution that is very cheap and it can work quite nicely using this technology. Yeah, guys, this is from my side. Thanks for watching, and I'll see you in the next video. Until then, and cheers.